Welcome to Vidyotma Physics. In this lecture, I am going to cover 3D resolution of vectors. Previously, we have in detail covered 2D resolution of vector, the link which is given in description. Here, our focus will be primarily on applications in physics. First, what is this 3D resolution, sir? 3D means whenever you represent any vector in x, y, and z components, that is simply 3D resolution. Sir, but all can't we represent only in x, y, y, z or z x components? No, there are some vectors. Let me give you example. Oh, this vector is there. I want to resolve this vector. So this is x component and this another is y component. Let me write. So this is x component, this is y component, and this is my original vector A. A vector is in xy plane. That's why there is no problem. But what if? Let me show you. This vector is in the plane of this board. Okay, this is simply in plane of this. What if this is slightly tilted like this? If this vector is slightly tilted, can you see that there is also a z component? Because this vector is coming outside this board, that means z component is also there. That's where we have to resolve it into third component, that is z, and that's what we call as 3D resolution of vectors. Are you getting it? So first you need to remember what is sign convention. Basic sign convention you must know, right? The x, y and z. So suppose this is x axis, this is y axis, and this is z axis. So z, positive z we take outside the plane of paper. Okay, outside if it is coming towards you. X is represented by I cap, J cap. These are the unit vectors. Okay, for representation of direction. This is K cap. Similarly, minus x if I have to go minus I cap. Here it should be minus J cap. And inside this plane of paper, here it is minus K cap. This is very clear. This is basic. Let us see how to get that vector. What are resolution? Okay, so suppose I draw any vector. This is our vector. Sir, how this vector is? Can you visualize? Yes. This is a type of cuboid. Can you see that cuboid? This vector is not in the plane. Okay, this is not in the plane. It is slightly outside the plane. It is like this, right? Now, this vector is making certain angles. Let us say it makes an angle alpha with x-axis. Then, which is alpha here? Which is alpha? This is alpha. Okay. Beta with y-axis. Where is beta, sir? Here it is beta. Okay. And there is gamma, which is with z-axis. There is a third angle, which I call gamma with z-axis. Alpha, beta, gamma are the angle with x, y, and z. Let us name this vector as A vector. This is my A vector. With color marker we will name so that it will be easy to understand. This A vector. I have to resolve this. Now, there are three components of this vector. One is x, one is y, and one is z. I need you to visualize this. What I will do is, first I will cover triangle law of vectorization. Where is x component, sir? This is x component, correct? Then I will go here. This is y, and where is z component? Is our vector addition completed? One vector, second vector. See, this is what? This is my x component. This is y component. And sir, I am not getting this. Actually, this is in here, outside the plane of paper. Okay. And where is that vector? Here is that vector, which is joining x, y, and this is z component. So this is my AZ. Okay, these are three components. How I will write, sir? You need to write A vector can be written as AX I cap for positive x axis plus AY j cap, again positive y axis, and AZ j cap. So what is the value of AX, AY, and AZ? That we will find. Don't worry. You tell me, if I want to find Ax, suppose this is my vector, and if I want to find Ax, what I will do? I will not change angle with x, okay? What I will do? I will simply project this vector in this plane. Simply project this vector in this plane. Can I do it? I am not changing any angle with x. Yes, sir, you can do. And this component is what? Cos component. In 2D resolution, I have explained. Hypotenuse makes angle with a particular side. If it is that angle is alpha or theta or whatever, so that side is cos. So this is cos. Okay. Can I say Ax is equal to A cos alpha? 100%. Similarly, if you can see here, if I project to check what is y component, what is this length, this component is nothing but y component. What is angle with y axis? Hypotenuse makes angle with whatever side, that is cos component. In y axis, what is the angle? Beta. So what I can write? Ay as beta. So Ax is equal to A cos alpha. Let me write. Ay is equal to A cos beta. Sir, why didn't you write sine? Because sine, see, cos alpha is this component. If I, in terms of alpha, if I want to write, then sin alpha I can write. But cos beta is also fine because we are interested with angle with y-axis. Okay. Sir, how to find z component? See, this is my vector. What you do? You project in xz plane. Have you projected this in xz plane without changing that angle? Okay. So which is that z component? So this vector is making angle gamma with z axis. If it is making angle gamma with z axis, this component is cos gamma. Okay, simply this component is cos gamma. So I will write Az is equal to A cos gamma. A cos, you need to remember this. What else we need to remember, sir? Once you get Ax, Ay, Az, A vector, magnitude or length. How to find, sir, magnitude of any vector? Simply it is what? Ax square plus Ay square plus Az square, right? So I can write under root of Ax square plus Ay square plus Az. I want you to remember an important relation. Derivation can also be done, but specifically for NEET and JEE, we will skip that. What is that? Cos square alpha plus cos square beta plus cos square gamma, important result, is equal to. Derivations we can do, don't worry, but numerical part is our primary. Okay, these formulas are important. What we have discussed, that if a vector in 3 dimension makes angle alpha, beta, gamma with x, y and z, then its x component is A cos alpha, y is A cos beta and z is A cos gamma. That's it. And sir, what is the relation? This relation you have to remember. We will mark some stars so that you can remember the formula. This is basic representation. This is component x, y, z component, and this formula is also in. Okay. Now let us see how to solve questions, because ultimately we have to solve questions in examination. Vector A makes 45, 45 and 90 degree angle with x, y and z. What is given to us? Whenever angle is given, that means what is given? Alpha is given with x axis 45. Similarly, beta is given. How much it is? 45. And similarly, gamma is given. What is that gamma? 90 degree. Fine. Also, magnitude of the vector is given. So I will write magnitude is also given. What is the magnitude, sir? 5. Okay. What is asked? They are asking x, y and z component. Just now we have written the formula for x, y and z component. Okay. Yes, sir. So let me write. Ax is equal to simply A cos alpha. Therefore, 5 cos 45. Cos 45 is how much? 1 by root 2. So answer is 5 by root 2. Simple. Similarly, Ay I can write A cos beta, that is 5. It will be cos 45 because beta is 45, again 5 by root 2. And Az finally is A cos gamma is equal to 5 cos 90. What is the value of cos 90? 0 or 1? 0. There is. So it does not have any z component and x and y component we have found. Let us take another question. What that question is saying. So this is simple question. When angles are given, components are asked. Another type of question. Find direction cosine. Okay, sir, what is this direction cosine, sir? I forgot to tell what is direction cosine. Whatever cos terms we have written, these are called as direction cosines. Sir, why direction cosines they are called? Why direction is involved in their naming? Because when I know angle with x, y, z axis, suppose I know angle of any vector, then I can easily draw that vector. Basically, that angle is telling me direction, correct? Na? That's why direction cosines. And another important thing, whatever ax, ay, and az we have written, okay, these are called as direction ratios. Okay, these are direction ratios. You need to remember this. Now, focus here. Direction cosine, that means cos alpha, cos beta, cos gamma is asked. Okay. Now, can you tell me from here what is cos alpha, cos beta, cos gamma? Simply, if I divide ax by a, I will get cos alpha. If I divide ay by a, I will get cos beta. And if I divide az by a, I will get cos gamma. Okay. Separately, if you want to write, you can also write it as cos alpha is equal to ax upon a. Cos beta is equal to ay upon a. And cos gamma is equal to az. Simple. Okay. So let us solve this question. So what is first? What is a? We will find a is nothing but magnitude. So magnitude is ax square plus ay square plus az square. Clear? What is this? Under root of 1 plus 1 plus 2, that is equal to root 4, which is 2. A we got, right? From a what we are getting? So direction cosine, that is cos alpha is asked. So cos alpha is simply ax. Ax is what? 1. 1 by, sorry, not root 2, it should be 2. Similarly, cos beta. Don't find alpha, okay? I know alpha is 60 degree because cos alpha is half. They are just asking direction cosine. So we will find value of cos alpha. Cos beta, sir, what is cos beta here? Cos beta is what? Minus 1 by 2. Why minus 1? Because here it is minus ay upon a, right? Similarly, cos gamma I can write. Cos gamma can be written as az, that is root 2 by 2. And that 2 has 2 root 2. 2 has 2 roots, right? That means what I am saying, 2 can be written as root 2 into. So this is 1 by. Easy. A formula based questions are asked from this topic. Okay, very easy. Sir, another question. Yeah, you wanted proof, right? Cos square alpha plus cos square beta plus cos square gamma. Another proof we will take, don't worry. What is that? They are asking value of sin square alpha plus sin square beta plus sin square gamma. Sir, cos square alpha plus cos square beta plus cos square gamma is equal to 1. Then sin square alpha plus sin square beta plus sin square gamma is also equal to 1. Don't be foolish, okay? Concentrate here. How to go about it? First, what we will do in such question? What you have to do? Sin square alpha plus sin square beta plus sin square gamma. Here the square formula is there. Square formula. Only one formula I have given. Square formula. Where is that formula, sir? Here I have told you that remember this cos square alpha plus cos square beta plus cos square gamma. Right? Therefore, I will use the same formula. Let us see if it clicks or not. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. Sir, but here sin is asked. So how to go from cos to sin? Do we have any identity? For square, which identity we have? A very basic identity. Cos square theta plus sin square theta is equal to what? 1. So can I write cos square alpha as 1 minus sin square alpha? Very basic. Don't ask how it came. Then 1 minus what I can write? Sin square beta. Then 1 minus sin square gamma is equal to 1. What you do? You add all ones. 1 plus 1 plus 1. Here it is 1, 1, 1. How much it is? 3. And minus you can take common. Because minus is there. This minus is there. I can take common. What I will get? 3 minus sin square alpha plus sin square beta plus sin square gamma. Beautiful, sir. Is equal to 1. Now you just adjust. You take sin square alpha plus sin square beta plus sin square gamma right side, and 1 you can take left side. So I can say 3 minus 1 is equal to sine square alpha plus sine square beta plus sine square gamma. Okay. So 3 minus 1 is what? So answer is what? 2. This is my correct answer. Very easy. Formula based questions only. Nothing. Another important question. Many questions we are going to discuss. If direction cosines of a unit vector, okay, what they are saying. If a direction cosines of a unit vector, okay, unit vector is there. What is unit vector, sir? Link is mentioned in description. Okay, you can find. And here direction cosines are given to us. Direction cosines means what? Value of alpha, beta, gamma, or cos alpha, cos beta, cos gamma. Cos alpha, cos beta, cos gamma. Okay. Represent vector in rectangular format. That means we have to find the vector. Initially, what we did here in this example, angles were given, and from that angles only components are asked. In this example, whole vector is given and direction cosines are asked. And in this example, direction cosines are given and vectors are asked. So how to find it? So, sir, first what you do? To tell us the formula for the vector representation. What is x component? X component is a cos alpha, y component is a cos beta, and z component is a cos gamma. But sir, what is a? What is a? Is magnitude of vector given here? Yes, it is given. Why? Because it is hidden inside words, right? So since a is a unit vector, so I will say its magnitude is what? 1. Because sir, it is a unit vector. Excellent. Once I know this, my journey is easy. How, sir? Ax x component is what? A cos alpha. It is simply 1 into what is cos alpha? 1 by 2. That is 1 by 2. Similarly, I can write ay as a cos beta. It is how much? 1 into, that is a cos beta value is minus 1 by 2. Here it is minus 1 by 2. And az is equal to a cos gamma is equal to 1 into 1 by root a cos gamma, that is 1 by. So finally I want to find a vector, right? So a vector can be written as what? A vector is nothing but ax I cap plus ay j cap plus az k cap. So I will write 1 by 2 I cap minus 1 by 2 j cap plus 1 by root 2 j cap. Array, is it easy or very easy? Very easy. So almost all type of questions we have covered, okay, in 3D resolution. Nothing more and nothing less than this is required. Are you getting it? So study well. All the best. We'll see you till next video.